Good morning, good afternoon, and thanks a lot to Small Cell Forum for inviting me to be part of the emerging technology and 6G session. The subject of my talk is on the path to 6G. Industry alignment and collaboration are key to make it a success. So what you see in this slide is that each new generation is about optimizing the new use case of the previous generation to reduce cost and introduction of new use cases. 6G will not only build on existing technologies, it will radically transform what a network can do. In doing so, it will liberate the human potential inclusively and sustainably. What we have been talking about so far is for the the unification of digital, physical, and human world, which would unleash the innate potential of human beings. So in this slide, what we see is that while 6G will be an evolution, the technology required to get there will need to be a revolution. So let us look at while today's 5G networks are starting to bring the future to life, 5G advanced and 6G are in great demand to fully realize it. Take the example high quality video. In 5G, we can do 4 to 8K video. In 5G advanced, we'll do extended reality, which is already a study item, work item in release 18, which will give you a fully immersive user experience. In 6G, we can do holographic transmission, or we can implement part of the holodeck. In 5G, we can do object-driven digital twinning, for example, on small objects like an engine, where in 5G advanced, which is release 18 and 19 of 3GPP standards, we can do large-scale digital reconstruction like in a vertical form. And while in 6G, it will be a broad-based digital twins with real-time synchronous updates like in a smart city. And with respect to positioning, in 5G, we can do data communication and control. In release 18, we propose to introduce the new services of precise positioning and resilient timing as a service, and it does not take much creativity to also convert this into low power tracing device. The main motivation for these new extended 5G services are to be an alternative and resilient solution to GNSS. It provides resilience to GNSS, it provides indoor service, and power consumption of terminals can be much lower. And in 6G, we'll introduce this network with a sixth sense, which is communication and sensing working together. So the 6G technology landscape from Nokia's perspective, it comprises of 6 new technology elements. One is called a new spectrum technology. We'll describe in detail a little bit later. AI native air interface, network as a sensor, extreme connectivity, cognitive, automated, and specialized architecture, and security and trust. These are the 6 pillars of 6G technology from Nokia's side, which we have been proposing since 2019. So looking into new spectrum technologies, it consists of spectrum sharing, millimeter and sub-terahertz technology, next generation massive MIMO. Digging a little bit deeper into it, this shows the 5G advanced and 6G spectrum options. In addition to exploiting existing 5G spectrum, additional spectrum is needed to enable kickstart 6G. So wide area CSPs and local area non-CSP deployments are envisaged also in the 6G area. Spectrum within the 7 to 20 gigahertz is essential as 6G pioneer band, facilitating for macro cell deployment utilizing the C-band site. So you reuse the C-band site and deploy this new 7 to 20 gigahertz band where you can improve the capacity and coverage by utilizing much higher massive MIMO, more antennas, and wider bandwidth. Additionally, sub-terahertz spectrum around 90 gigahertz can offer potential for local area, ultra-fast, low latency 6G services. Not only that, it will help also in providing backhaul and fronthaul services. So this above 90 gigahertz band is very expensive, and initially it will be used for fronthaul as well as for backhaul. Also, it is expected that 6G will operate both in licensed and unlicensed mode. It is expected that spectrum sharing will play increasingly important role in the 6G era. So moving along, this is one of the other important aspects of 6G, which is the 6G AI native interface. Initially, this is a classical one. We have an encoder symbol mapping, modulation, waveforming, and the receiver consists of channel estimation, equalization, symbol mapping, and decoding. Initially, 5G Advanced, which is release 18, it will replace, enhance individual processing blocks like channel estimation, the beamformed access processing block, symbol decoding, etc. In 5G Advanced, the next stage will happen, machine learning will replace multiple processing blocks. And finally, in 6G, machine learning will design as a part of their interface, which will consist both the transmitter and decoder. We'll talk about network as a sensor, which I talked about. This is sensing plus communication is one of the important areas of 6G, which we call it simultaneous communication and sensing. So with increased network densification, use of wider bandwidth, massive MIMO beamforming, and sophisticated AI-based signal processing built in the system for communication, radio sensing from the same infrastructure is an exciting new possibility. For cellular networks, it can create new services indoor and outdoor for operator to offer to customers. Optimizing their interface for joint communication and sensing can result in significant deviation from current 5G specification that a new generation of air interface will be more appropriate. So in communication sensing in 6G, we are looking at waveform multiplexing, resource allocation, beam sweeping, CSI-based sensing, of course, high precision localization and non-line of sight. Next, we'll briefly move into North American 6G vision. So the NextG Alliance aims to engage a diverse ecosystem consisting of operators, vendors, hyperscalers, research groups, universities, and government representatives. The stakeholders within the scope of the NextG Alliance include policymakers, government leadership, application developers in vertical market, research scientists, engineers, and more. So developing a vision that spans multiple layers in 6G ecosystems and drives North American leadership for the next decade is one of the key objectives of this alliance. It consists of national imperatives where we describe the societal, economic, and governmental factors that drive each objective. It sets a bold and clear vision that describe the change that will be realized with 6G compared to 5G and describe the unique needs and leadership opportunities from a North American perspective. Then we have applications and markets where the key markets and use cases are enabled by realizing the vision and consider codependencies with adjacent industries and groups. Finally, the technology development in this aspect, we identify the key technologies or new technology areas that are needed to achieve the success of each objective and why these objectives cannot be met with 5G technologies alone. Key performance indicators are also identified to set success criteria for the technology objectives. So the NextGen Alliance working groups consist of 6 working groups. So I am the chair of the National 6G Roadmap Working Group. So there is this application working group, the Green G working group, the Societal and Economic Needs working group, the Spectrum working groups, and the Technology working group. And so all these working groups are contributing heavily towards this 3 objectives I mentioned before, which is national imperatives, applications and markets, and technology development. So this slide shows the North American 6G vision explained. So at the Roadmap Working Group, we have enabled these 6 audacious goals, which consist of trust, security, and resilience, digital world experience, cost-efficient solution, distributed cloud and communication system, AI-native wireless network, and sustainability. So in terms of trust, security, and resilience, the 6G system will be trusted by people, businesses, and governments to be resilient, secure, privacy-preserving, safe, reliable, and available under all circumstances. A digital world experience is very important. It will support multisensory experiences to enable transformative forms of human to human, human to machine, and machine to machine interaction that bring life-improving use cases and create new economic value. So one of the primary use cases of digital world experience is the XR, AR, and VR. Next is the cost efficiency in all aspects of the network architecture must be improved for delivering services in a variety of environments, including urban, rural, suburban, and also indoor, while supporting increased data speed and services. Distributed cloud and communication system, 6G will provide distributed cloud and communication systems where communications and unified computing services work together and scale across devices, network, computing resources, and data centers. I talked about the AI native wireless network. A future is needed to increase the robustness, performance, and efficiencies against more diverse traffic types, ultra-dense deployment topologies, and more challenging spectrum situation. And finally, the sustainability is very important. 6G will be designed with sustainability in mind from the very beginning. It will reduce environmental impact, it will be more energy efficient, and implement circular economy principles. So this slide shows that Nokia is driving towards one global standard as it will benefit all. We compared the Nokia 6G technologies versus the NextGen Alliance. So what we see here, that the trust, security, and resilience can be mapped into security and trust in our vision, in Nokia's vision. Digital world experience can be mapped into network as a sensor and extreme connectivity. Cost-efficient solution will be very directly related to the new spectrum technologies, which we discussed earlier. Distributed cloud and communication system is similar to cognitive, automated, and specialized architecture or new architectures for 6G. And finally, AI native wireless network is mapped directly to AI native air interface, and while sustainability will be part of the whole RAN system, where we want to make the data centers, the RAN, and the UE devices sustainable and energy efficient.
Thank you.
And it maps to cognitive, automated, and specialized architecture. So finally, in conclusion, what we see is what While 6G will be an evolution, the technology required to get there will need to be a revolution. We identified the 6 component of technology landscape, which has been defined by Nokia since 2019. NextG's 6 audacious goals create the framework for advancing North American leadership and positioning a robust 6G marketplace. Nokia's 6G technology vision is quite aligned with the North American and global 6G vision. Thank you for giving me the opportunity to present at this forum. Thank you.
Hi, everyone. Warm greetings from Ravi, Sinha, Director Reliance Geo for Product and Technology Development. And along with what I do with Reliance, definitely I'm also active with SDOs like the Small Cell Forum, ORAN, and a lot of other open source initiative. Today's talk will be under your SCWS US chapter. And we are going to talk about 6G, specifically on Autodrive Limitless connectivity with the next generation services. So this is going to be a very interesting talk because 6G is still evolving, but working with 6G for the last, I will say, a year or so, I have realized that this has got enormous potential, not only in terms of connectivity, but also in terms of disruptive service chaining and creating a very unique ecosystem around it. So today's talk will be very much based around it. So let me show my presentation so that we can go as per that. 1 second. So I hope you are able to see my presentation with the recording. So a couple of things I would like to quickly check. The first thing is that what is the spectrum? And let me put it to a presentation mode. So a spectrum at present, like we are working, I think most of the industry is working from 100 gigahertz to 300 gigahertz. But of course, I'm sure that academia and a lot of other folks who wanted to kind of explore something to the upper higher end terahertz communication, which is 300 terahertz to 300 gigahertz to 10 terahertz. And these are the two ranges, as you can see. When I talk to academia, they're more focused from 1 terahertz and above, whereas the industry is at present focusing, along with the silicon, focusing 100 gigahertz to 300 gigahertz. So 2019, when I think some of the baseline work started, expected deployment 2028, a lot of Korean government, Japanese government, they are interested to bring it even early. At present, the United Nations Sustainable Development Goals, 6G is targeted 2030. 3G definitely, we are targeting 2030. Of course, ORAN is also very excited to to work in the direction. The Small Cell Forum, definitely all the SDOs, they are interested to work in their specific domains where they have their strength. The government worldwide are very much interested. Even India has announced that we are going to come up with 6G on time, or a lot of research activities already also started in India. I work for Reliance Geo. Reliance Geo is the largest MNO operator in India and the second largest in the world. So definitely very excited about 6G activities. So let me go to the second page. So as you can see, the vision of 6G, basically all the enablers, I'll go one by one, starting from sustainable development, then massive digitization, native AI security as a service, physical and human programmable world, robots and cobots, digital twinning, connected intelligence. These are some of the kind of upcoming demands in terms of services, and then the enabler fabric, which is going to add a lot of value to 6G. They are kind of cross-feed each other. If we go in terms of technological evolution, limitless cognitive infrastructure and connectivity, connection and connectivity everywhere, that is the need and demand. Of course, decentralization, next generation edge framework, compute fabric everywhere. These are something which we all needed. This is the word for DeFi, DApp, and many more in terms of Web 3.0 and going to Web 4.0. So definitely a lot of excitement in this area. Spatial computing support, data everywhere, open human and machine interfaces with AI fabric, intelligence everywhere, economical trends, next generation service and business framework for socio-economical empowerment, discovery, digital sustainability, social and content curation for individual, community, and society. And of course, user experience, immersive digital experience coming from AR, VR, MR, segue to metaverse. Metaverse is something where I'm sure that most of the SDOs are very much interested, because metaverse has got the last, like the 3 or 4 layers, you can say mandatory, coming from the telco side of it or wireless infra side of it. So these are the visions, some of the enablers for 6G, and then how exactly it is partitioned into multiple segments and how they cross-feed each other. Revenue potentials, as you can see that starting from health, logistics, and transport, cities, worksite, factories, many $1 trillion of economy, you can say. And then definitely this is coming from McKinsey Global Institute, referred by 6G Flagship. So there are 2 ways, like one is your low estimates and high estimates. Even for factories, it is 3.3 trillion, a kind of a worksite close to $1 trillion, cities 1.7 trillion, logistics and transport close to $1 trillion, and health close to 1.6 trillion. So a lot of potential. It all depends how it evolves and what domain is given the priority based on the kind of services keep the traction and scale. So that is a revenue model. This is how I can see that the connectivity and the service, they are interdependent, since the injection of artificial intelligence with 5G is again going forward with a 6G with many more options to decentralize, as well as a lot more cloud native assets going into the deployments, as well as the challenges related to native security and native artificial intelligence in terms of SMOs, the SLA management and QoS or end-to-end. There's a lot going to disrupt the whole architecture. So this is how we envision how the connectivity side, which is the bottom, is properly aligned with the next generation services like metaverse, DApps, DeFi, agri-tech, industry 5.0, automotive, all are being orchestrated at their relative ends, and then talking and cross-fed to a federated artificial intelligence and machine learning level, where kind of based on whether it is a public enterprise or industrial consumption, it can, like the federated can generate a lot of cross-domain AI for the different kind of consumption. Federated native AI, industrial, major interest, major challenges, major changes in terms of native AI due to highly decentralized nature of 6G networks, heavy demand for cross-domain federated AI for infrastructure and next-generation service, which includes user control and management planes, AI and SMO level cross-coordination among RAN and core, evolution of network controllers, which includes radio intelligent controllers, and DAF and higher level SMOs, Web 3.0, as I said, going to 4.0 in terms of NFT, blockchain, DeFi, DApp, IPFS, and smart contracts. Inference all up to the lowest layer of the network modules, going all up to DU if it makes sense in terms of scaling, in terms of economics. So all these things need to be explored. So 6G native security, decentralized approach, as you can see, 6G is going to be an AI empowered network and possess a huge threat for security because of the quantum compute is also going to be aligned at the time. That's why injection of quantum encryption is required. And then 6G will also enable enhanced machine type, massive machine type communications, 10 million per square kilometer for enhanced in Industry 4.0 and beyond. It is also going to pose a great threat, as I said, and the injection of quantum encryption is also going to be a big demand. Nowadays, even with 5G, a lot of industrial requirements are pulling these things in. Solution framework for 6G security, build the security framework, which is AI-driven, cognitiveness framework, where the focus is detecting the seemingly undetectable threats and predict in advance, adding the cyber resilience support to support a unique and unprecedented threat within 5 years, even with 5G, EU and USA all. In Asia also, as I said, that quantum encryption is going to be over there, 2 flavors, QKD, quantum key distribution, as well as the post-quantum, which is outside the optical fiber network specific to encryption. Native security based 6G network architecture, which will be highly decentralized, privacy aware and zero trust architecture will be the requirement for native security. Adversarial ML robustness and protection against attack based architecture, secure native design for independent data control and management planes, addressing the quantum computing threat. These are some of the areas to be thought of. And of course, quantum encryption, major area of interest with the industry, as you can see, SASE 2027 trials and 2030 deployments, quantum cryptography, then securing the 6G infra in terms of SSE, enterprise infrastructure and application security. These are the 4 areas I think going to be the deterrents for the quantum cloud and different kinds of security, which is a replacement of the PKI. So that's what I have. Some of the major 6G use cases: cognitive network, connected sustainable world, network compute fabric, programmable physical world, limitless connection, connected intelligent machine, the internet of sensors, digitized and trustworthy systems. So these are close to 7-8 of the prominent use cases. Very excited to be the part of some of those research and developments in terms of white papers and research reports. So you'll be seeing a lot coming from a lot of SDOs I belong to. So very excited about all these use cases and the research is going around it. So that's all kind of quick, you can say, a glimpse of what the limitless connectivity will bring. So let me stop the share. Definitely, I'll be very excited to share some of the upcoming things from the SDOs I work with, especially SCF, ORAN, and enterprise neural systems. So a lot of things to share in future. Definitely soon, like we'll be the part of the panel where we'll discuss the holistic view of 6G. So I'm very excited to join that discussion panel. So I would like to stop now, but I will be excited to hear from the other panelists as well as some of the other presenters about their takes and thoughts on 6G under SEWS US chapter. Thanks a lot. Take care, everyone. Bye-bye.
Well, hello, and thank you for attending this session. I'm Mazin Gilbert. I'm a Director of Engineering for Telco Analytics and Automation at Google Cloud. And I'm so excited today to talk to you about cloud analytics and automation for 6G and beyond. So this is really the vision of driving an autonomous network as we evolve from the 5G to the 6G framework. First, I wanted to share with you what are the pull here? What are the applications that are requiring us to start thinking even today about 6G and what beyond basically 5G? This is a chart that comes really from data from ATIS categorization, IoT categorization, thanks to one of my ex-colleagues at AT&T who put this together. But think about really characterizing G in terms of two dimensions. There is the data rate and there is the end-to-end latency here. And as you could see that we've been evolving from the 4G LTE, where we've made some significant revolution in things like streaming video and really trying to get high bandwidth to the point where we can have this kind of a conversation, we can have these kind of meetings in a virtual environment. We're just starting the 5G evolution here. And in this 5G, we're really enabling high speed type of throughputs, low latency in the order of a few milliseconds. And with those, we're able to enable sort of manufacturing efficiencies, autonomous vehicles, some AR, VR. We're starting to see glimpses of those, and those will really evolve over the next 5 to 10 years. As we depart 5G later this decade, and by 2030, we get into the 6G commercialization. Really now we're starting to see some exciting new applications. So think about, high precision networking, holographic communication, practically being there, in your digital form, all the way to some new pervasive XR experience and 3D imaging. To do those, you will need to have some very sophisticated real-time communication, machine learning and AI, and fairly sophisticated sort of data ingestion analytics. Data rates here is in the hundreds of gigabytes. That's what's really required within the sub-millisecond type of latency to enable this extreme real-time communication. Question is that there are many, many hurdles to getting there. And really, there are some foundational challenges that have to be defined before we can get there. And that's why 6G is not just another G. 6G is a transformational paradigm that needs to include automation and machine learning by design, not an afterthought, which really has been the case in 4G and 5G. We have a long way basically to get us there. We need to operate this advanced 5G and 6G networks at very ultra high frequencies. This requires scale. We are not scaling today, just looking at how we are thinking about 4G and 5G. There are some challenges with densifications and really optimal network design that can minimize cost and really maximize coverage and minimize interference. Till today, the way we're building 5G is sort of the same as how we're building 4G, very manual intensive human touch. And really we need to start making some big breakthrough where we're driving that zero touch programmable network, this autonomous network that we are yet to be attaining. So that's why I think of 6G is not another G. It's just not another 5G. It is a transformational paradigm where automation is really done by design. Why do we think we're going to get there? Because now we're starting to turn the wheel. During 5G, we're making the transition. We're making the transition to this framework, the transition where we are driving the network towards cloud native to make it programmable network, virtualized, disaggregated, and really support open and standardized interfaces to get to that multi-cloud, to that multi-vendor or vendor agnostic, basically, paradigm. To get there, there are architectural, technological, security, data sovereignty challenges that we basically need to address. It's not really going to happen without addressing those challenges. And this is really the right time to make this happen. So I want you to start thinking about the world today and the world about a decade from now. We're leading with the world today, which is really centralized services and compute. And that's really going to be transformed to cloud native, to distributed cloud compute and intelligence. We're starting to see the glimpse of that already. We're going from disparate architectures, the way we're thinking about 2G, 3G, 4G, 5G, the way we're thinking about Wi-Fi, wired versus wireless. These are all disparate networks. And we are really moving towards this ubiquitous architecture across all networks, where you're getting the best connectivity, the best coverage, the best signal at any point in time. We're going from this monolithic proprietary networks, even today with 5G, and we're moving towards this open and standard-based type of networks. There is, of course, significant OpEx spending even till today. We can't scale to go to that highly densified network with 6G. And that zero-touch autonomous network is absolutely required, which means that we need to move away from this high-touch physical world that everything needs to be checked by a human to really low-touch digital twin. Data, which is the intelligence of managing this network to driving the OpEx, is really disparate. Many copies everywhere. Access privileges is a challenge. Data sovereignty is a challenge. And really moving to this machine learning, cloud native, cloud-based data sovereignty world where data is your biggest asset in driving and operating an efficient 6G world. So let me touch a few of those points that I just mentioned. The first one I want to really talk about is distributed cloud intelligence. So as I mentioned earlier, now we're going from this regional centralized core cloud with a lot of on-prem proprietary hardware and software to really think about a distributed cloud, where the cloud really starts at the customer edge, at the enterprise edge, all the way to the core, all the way to a regional cloud. And really workloads are distributed across this ecosystem. At the customer edge, workloads really demand very high intensive, real-time machine learning analytics and very, very low latency for that real-time communication. Imagine monitoring defaults and defects in a manufacturing sort of ecosystem, all the way to the regional cloud where we are really running very highly sort of intensive, large volume machine learning capabilities that may require terabytes of data to be consumed in order to build the best of the best models. And those models are being adapted. And there is some non-real-time control is happening there in the order of seconds, whereas we're talking about sub-millisecond type of control when you're looking at the customer edge. And now you're seeing the workloads ranging from the customer edge to the operator edge to the cloud edge to the regional cloud. And the most fascinating and exciting and the most challenging problem in this ecosystem is really figuring out how do you orchestrate workloads, application workloads, network workloads in this ecosystem so you attain the optimal SLA in terms of performance, in terms of latency, in terms of security, etc. So I'd like to give you this sort of show you this picture of how we operate our Google network. We are pretty much very close to a zero-touch autonomous network. The network pretty much 99% plus of the time is running on its own. All the faults, all the issues that happen in this network are addressed pretty much automatically on their own. It's an intent-based network. We have these intents that describe the object, the plan, the target, the desired state of this network that really gets to be translated into and compiled into a set of actions and the actions gets to be orchestrated through APIs. And you have sort of this orchestration closed loop with the analytics and machine learning that pretty much collects the data, monitor the network, take actions, and basically continue to optimize this network. The network itself is fully digital twin representation that we have. That topology, that network topology is pretty much encapsulated in a computer where we run billions of simulations a day to really understand the scale of this network, the disaster recovery of this network, the scalability, the scale of this network. Really important part of really driving an autonomous network. This is the vision that we're bringing in as Google, and this is sort of what we're working with a lot of partners to embrace this vision and capitalize and really make it really real as we embark into the 6G world. Let me touch a few of these points that I just talked about. First thing I mentioned is that we need to go from physical appliances to virtualized machines. We're starting to see that already. We've seen that several years ago. Now we are starting today to see some of these virtual machines moving towards containerized services. Well, we see containers already today. We in fact use Kubernetes today for a lot of applications, whether it's for compute, for networking, for storage. But we're moving towards this new world where we really need to have cloud native containerized services also for network functions and applications. And that's sort of where we need to extend Kubernetes to that next level. And a couple of weeks ago, 3 weeks ago, we announced this community on the Linux Foundation called Nokia to do exactly that, standardize a lot of the interfaces with the OSS and BSS system, and being able to manage these cloud native network workloads in this distributed cloud environment that I just talked about earlier on. Another area that I'm really very excited about, which is where I see 5G is transitioning us there, and 6G is going to be our target, is really standardizing the interfaces and making the network programmable for both RAN and core. And thanks to a lot of amazing work done by the community for ORAN and NWDAP, we're basically getting there. And we're now transforming that ecosystem to cloud native and standardizing those interfaces. This is really very important because what this means is that we'll end up with a world where we are pretty much application vendor agnostic, that you can plug and play applications in this ecosystems across clouds, across vendors, without really having to worry about this sort of proprietary interfaces that we basically exist today. You start thinking about things like service management and orchestration, like SMO, not as a monolithic software that comes from one vendor, but really as a disaggregated components that sits in a cloud. This is really important because that is where the data is. That is where the compute is. That's where the elasticity is. That's where the intelligence and the machine learning is. So being able to disaggregate this ecosystem, to be able to place these controllers in the cloud, to place the data platforms in the cloud. And each of these pieces may come from very different vendors, all operating and supporting standardized interfaces. And depending on the SLAs, we could do non-real-time control all the way to near real-time to real-time control across basically core, transport, and RAM. This is the world basically that we're building in 5G, and it's going to be real in the next several years. And by 6G, it becomes the de facto of how we operate. One area I'm really excited about to really drive our CapEx and OpEx down is really building this telco digital twin. We're starting doing that with a number of partners globally. Why is that important? Well, today, if you think about how we operate and design a network, is mostly based on network congestion. In the cellular side, we look at basically PRBs, busy PRBs. In the wireline side, we look at the throughput, how much traffic is going through basically the pipe, and understand what the traffic congestion is. What we're really driving towards is a world where we're optimizing the end user experience, because that's really what it matters. And by doing that, we would be able to put our dollars more efficiently in building that network and operating that network. And to make this a reality, we're really rebuilding the world of the telco in terms of this digital world. We're using very high resolution digital imagery, whether it's streets or aerials or satellites, and creating what that world looks like, where the antennas are, where the buildings, where you can place the antennas on, what kind of antennas those are. Are you able to place an antenna there? And if you place the antenna there, what is the signal strength and the coverage outside the building, inside the building? And so you can imagine being able to create billions of these simulations a day to truly come out with the optimal sort of design that basically can drive this network. We can't do this without solving some fundamental issues. 6G will never happen as a breakthrough revolutionary framework unless we address some of these challenges that I'm showing you on this slide. These challenges, there are a number of these challenges, and I'm not going to go through each one of those, but all I want to mention is that, let me pick a couple of those. Energy efficiency, which is really important. If you think today, telco spends billions of dollars a year in terms of energy bills, and it's increasing. And so it's very important to go into this programmable network where pretty much everything is software-based, riding on commodity, highly efficient hardware. Pretty much the only hardware that you have is the computers and the antenna and a bunch of generators. And in this ecosystem that everything is managed, controlled by machine learning, by closed loop automation to really minimize energy consumption around the clock globally. Another area that I mentioned is scale. We must address scale for us to attain an autonomous network in 6G. And scale because we're dealing with high frequency, ultra high frequency operation for planning and running this network. But it means that we are dealing with massive densification. It means we are dealing with a lot of challenges with respect to intermodulation interference across cell sites, interference and blockage when the signal enters basically a building. These are fundamental problems we need to solve for us to get to that level. And I'm really excited of a number of activities like rings and ML wins. These are a number of activities globally sponsored by industry and the government to enable research in this paradigm shift. This research is absolutely vital in the next 3 to 5 years. So we can start doing trials on networks in 5 to 7, 8 years from now. Then we can take that into the standard communities. And then we can start doing commercial deployment of 6G in around 2030. I want to leave you with this slide. I hope you enjoyed this presentation. If you'd like to get more details, don't hesitate to reach out to me. Or we have a book. This is edited by me and published and written by 30 other incredible authors around the world. All royalties go to Black Girls Code. Thank you very much and have a wonderful day.
Hi, this is Chris Pearson. I'm president of 5G Americas, and I'm honored to be here for this really important panel at the Small Cells Forum USA. And this is going to be a panel on emerging technology and 6G. So there's a lot going on in the industry right now with 5G, and obviously I'm president of 5G America, so I'm very bullish on 5G and where we're going with it. But this panel is going to be talking about what's next. What are the emerging technologies that everyone is starting to look at and research? What's going to be the next generation on 6G? And what are we learn from maybe the 4G and 5G experiences as we move into this new generation of technology? I am extremely honored to be the moderator of this panel, and I'm going to allow each of my panelists just to do a short introduction, 60 seconds about who they are, their company, and what they're responsible for. So won't we start with Dale quickly?
Yeah, thanks, Chris. So hi, everyone. It's a pleasure to be here today. And I'm Dale Seed. I'm from InterDigital. And at InterDigital, I'm involved in various activities ranging from standards in 3GPP, IETF, do some research as well as product development. I'm very heavily involved in 4G, 5G, and now 6G. Most recently, I've been working with the NextGen Alliance in North America, and they're looking at 6G use cases, requirements, technology. And so hopefully I get to talk a little bit about that today, and it's a pleasure to be here again. Thank you.
Great. Let's just next go to Ravi.
Hi, everyone. Warm greetings from Reliance Geo. I'm the Director, Product Development, Technology Development, and multiple other domains. But along with it, definitely I chair 3 different initiatives from the 3 different SDOs. One is, of course, a Small Cell Forum. So I chair Emerging Technologies Group, where I'm also leading 5G enterprise solutions and blueprints. Along with that, I also chair 6G initiatives by ORAN. As well as there is another initiative called Federated Artificial Intelligence, started by Enterprise Neurosystems. So kind of very excited to be the part of the discussion, working with 6G for the last 1.5 years. So very excited to be the part of this discussion with Piers, Dell, and Meji. Thank you.
All right, next, Mazin, short introduction.
Yes, hi. It's an honor here to be in this panel. I'm Mazin Gilbert. I'm at Google Cloud. I'm a director of an engineering director for telco automation and analytics. Responsibility of myself and my team is to really drive more of our enterprise and telco customers to move to the cloud and help them to achieve their vision of an autonomous network. Previously, I was with AT&T, spent about 30 years there. So rich background in telecommunication. A lot of it is really focused on helping telcos to be more data-centric and automation-centric as they're building their network. Glad to be here, and thanks for the invitation.
Yeah, great to have you here. So I guess my first question kind of sets the foundation. Like I said, I'm president of 5G Americas. I feel like we're in the early stages of 5G. And here we are on this panel speaking about emerging technologies and 6G. So let me just, I really want to get everyone's viewpoint on this because it is kind of the foundational question of, is it too early to be thinking about or speaking about 6G technology when we're in the, we're in the early innings of the baseball game here when it comes to 5G? Why don't I start with you again, Dale?
Yeah, sure. So, yeah, you said we're in the early innings. I think from a deployment perspective, I would tend to agree with you. the 5G deployments are definitely rolling out in the early stages. However, if we kind of back it on up to when did we start looking at 5G technology, and when did the pre-standards work start? When did the standards work start? There was a fairly long cycle of work that started many years ago. So I would say on the 6G side, we're probably doing that even a little bit earlier than we did in 5G. But I think we're learning from that, right? I think it does take a fair amount of work and effort to kind of get the whole research community, the whole ecosystem kind of agreeing. And oh, by the way, it is a global technology. That means it takes even longer to reach consensus at a global level. So what I'm kind of seeing in my work with 6G is we're talking about technologies that could end up being within 5G and 5G advanced. They could end up being in 6G. And we're even talking about some technologies that may not even make it into 6G. So the discussions are very early on, just trying to survey the industry about what could be there in 6G. And what we'll probably find is it will probably be a little bit of a mix, of stuff that goes on. And we'll talk a little bit more about that probably throughout the call here today. But maybe I'll turn it over to somebody else to talk. Yeah.
Yeah. How about you, Ravi? Is it too early to talk about 6G? I mean, Dale made some good points. We're early on in some ways, but these things take time to build consensus. There's a lot that goes around a global standard, things like that. But is it too early, Ravi, or are we about right or a little late?
No, I think we are on time, Pierce, over here. If you can see 5G, the trends developing with the operators, at least the SA-based deployments already started. So I can see that it is tending towards a maturity. In terms of the total number of subscribers for 5G is going to touch base somewhere, I'll say 60–70% in coming 1–2 years. So I think deployment wise, India was a little late in terms of spectrum auction, but I'm very positive that this year, even the trials for 5G will start with full-fledged. And in terms of 6G, as I was saying that although like 3GPP 2025 is the target, where the specs will start coming, 2030 is the target. But a lot of countries like Korea, Japan, China, America, they all are so aggressive to have some POCs coming in 2025 to 2028 timeframe, which is very good. In terms of silicon or wafers also, if you see, transition from a standard proprietary hardware to a cost-based software, and then now more and more coming from AI and all. I think silicon side as well as server side, edge infrastructure side, I feel that we are prepared to go for a 6G trials in coming 3 to 5 years. I'm very optimistic that 2025 you can see a lot of POCs coming, although at the time even the specs will not be ready, but some of the mix and matches you can see in 2025 to 2028 time. Yeah.
Well, pretty aggressive that's an aggressive timeline from what I've heard. But we'll get to that timeline question in a second. But I want to ask you, Mazin, you had a lot of experience in telecom. And you, Mazin, has probably seen lots of generations, just like myself. What is it too early to be speaking about 6G, or you think about right?
I mean, I agree with my fellow panelists, is that it is not too early. For a couple of things. One is that we tend to think about the Gs to be completely distinct, separate, like pretty much we are removing the previous G and coming to the new G. And the reality is that even when you look at 5G and we have the early deployment of 5G, some telcos, by the way, have not even started any deployment in 5G. 5G is also an evolution over time, over the next decade. It starts with looking at the core, start with the core being sort of 5G non-standard, going to a standard. Now we're starting to look at the RAN. We're looking at the transport. So that by itself is an evolution. 6G will be the same thing. So the jump from a 5G to 6G is not going to be overnight. Everything just changes just remarkably. The second thing I wanted to make is that there's an evolution in every product. You start with research. You start with an R&D. Before even you do the POC, we're starting to see a lot of research by NSF and global research, programs like RINGS and ML-WINS and others, where they're really starting to look at what 5G has not done, What are the challenges in 5G? And this is exactly the fertile ground right now, is to figure out how we can address some really challenging issues that we did not address in 5G, do some research in that. And that would lead to the POCs that Ravi was talking about. And that would lead to sort of getting the community to standardize those. And then we will start with the deployment and figuring out the hardware, et cetera. So that takes time from the previous history. It's a decade per G. This is not going to be much different.
Okay. So this next question then it follows up to that. And I'll start with each of you and just, I know you guys had some blurry time frames there, right? But if you were to say in literally 30 words or less, what's the timeline for 6G is, what would that be? And Mazin, I'll follow up with you just because you just answered the last thing and said things are going to be blurred. But if you were to if someone put you on the spot, you know, The Price is Right or some type of game show, I don't know, and you're on stage and someone says, what's the timeline for 6G? The timeline for 6G is, and you have about 30 words or less, what would that be? Mazin?
2030, when commercial scalable deployment starts.
Okay.
It's going to take a while.
Okay. Dale, the timeline for 6G is?
I would say, I'll give you two answers. One from a standards perspective. I think somewhere in the realm of 2028, you know, we'll probably come out with like a release 22 of 3GPP that might be the first deployable type of standard. And that kind of lines up with Mazin on maybe a 2030 timeframe for, you know, an operator and going out with the deployment of that standard. So something in that realm.
All right, Ravi, you're on the game show. 30
Sure.
words or less. Ravi, what would be your time frame?
2028 to 2030, that will be the time. 2028 POCs, 2030 commercial deployments. As a kind of Dell and Mazin rightly said, that the timeline is very close, and I'm very sure that that will be the time where metaverse is a major disruptor, and sometimes I feel that it may even pull in things much earlier than projected.
Okay. Well, I definitely want to get to you each alluded to some things about emerging technologies and things that are being developed. So I want to get to those. But first, I want to say, you know, what as we look to 6G or the next generation, what have we learned as we have lived with 4G for quite a while now, and now we're in the the middle of 5G deployments and more devices. Have we learned from the 4G and 5G experience as we look at the 6G what we want it to be? And I know we can get into maybe even emerging technologies on this questions, but what is it that we maybe have learned in the 4G, which again been around a long time? It's a great technology. 5G, great technology, and still a long innovative roadmap for 5G with 5G Advanced. But have we learned from those experiences as an industry as we look at, well, what do we want 6G to become? I heard the timeframes 2030. So what do we want 6G to become? So any of you can answer this to start out. I'm fine with.
Sure. If everyone is okay, I can go first.
Sure.
Tell you the fact, like think about it, what 5G has done, and even like 5G Advanced is going to do. I think one area where we still felt that a lot needs to be done in terms of a control plane, user plane, management plane. Management plane, we have seen a lot of automation. Whenever we talk about artificial intelligence, machine learning, we've only talked about management plane. But user plane and control plane, these are the two areas where heavy uses of artificial intelligence and ML is required. The reason behind that is all the next generation services like metaverse, digital twinning, remote rendering, all those areas, they need a cross-stack optimization all through, starting from the wafer to software to firmware to the service chaining, and all those areas are still untouched, tell you the fact. And then a much more powerful compute fabric, as well as your floating point operations, remote, you can say, communications and sensing. These are some of the areas which are never touched. So I feel that because of the metaverse and multiple other use cases coming, they need to have these feature functionalities getting attached or getting trialed, even because the bandwidth is so high in terahertz communication, like FEC and others also needs a much powerful accelerator engines and platforms. So I still personally feel that those needs advanced way of computing, advanced way or much southbound artificial intelligence and machine learning going to that. Native security is another area because of the quantum is coming within 3 to 4 years. Quantum will also be a major challenge. So quantum encryption is the need of the hour. So all those things are also telling you that you need to have the disruption coming sooner than later.
Let me add to what Ravi said, if you don't mind, Chris. So I agree with whatever Ravi said. I think we've learned a lot how to make this an oil machine. Is we know how to get the standards, we know how to do the POCs, we know how to get the vendor community, we know how to get the chipset in place, we know how long that will take, we know how to deploy a site. Okay, we know how to work with our vendors to deploy the sites, we know how to gather the data. That's an oil machine. We've learned it from the 3G and the 4G, and we are applying it to the 5G. But I think one thing we've also learned in the 5G is that we are in the current oiled machine that we have doesn't scale to the level that we are trying to do with 5G started that we're going to change the world by having this, gigahertz sort of spectrum, millimeter wave spectrum. It's going to be everywhere. It's going to be in every corner of the world. And the answer is that we've sort of failed in doing that. And we decided as a global industry that we will go and focus on the macro cells for a while. And the small cells will be in the small arenas, in the small theaters, in the small sports centers. Part of that is that we cannot scale. We cannot scale in terms of manpower. There's a lot of human intensive effort required in building, planning, and deploying these cell sites. There's a lot of cost required. This is pretty much prohibitive when you're trying to think of that at the small cell level. So one of the things that we've learned is that we don't have the right weapons to scale. Ravi talked about automation of the control plane. Completely agree with that. One of the things we need to do with 6G is that automation and orchestration and programmable network needs to be part of the core design, not an afterthought. And I believe it's being like an afterthought in 5G, and 6G will have to be revolutionary different.
Okay, Dale, it's a key question here, and I'd love to get your opinion on what we've learned from 4G and 5G as we look to 6G.
Yeah, I think, some people that aren't necessarily kind of heavily involved in this, they might think that, with each G, we just start with a clean sheet of paper. And that's really not the case, right? So I think it's really a matter. I think the key in all of this is really kind of identifying the pieces that we want to bring along for the ride and we're going to evolve further. And then the revolutionary pieces that we want to kind of really maybe design from scratch and or overhaul. And I do agree with Mazin that the whole orchestration piece definitely, that was probably more of an afterthought. We got the 5G core network to be service oriented. We can now have virtualized network functions. And now the operators kind of looked towards the cloud providers to help them with the orchestration and management piece of it. I think bringing that more into the front end design piece would be a great move from an industry's perspective about how do we scale this thing more effectively, as well as just kind of identifying maybe some of the functionality that we definitely want to bring along with that, as well as something that maybe we don't. Just a point of reference, like with the revolutionary 5G, we defined a new radio, right? We made the core network service oriented, but there was a lot of evolutionary stuff that came along for the ride. We continued exposing services to the outside world from the core network, and that's a good thing. So we want to continue to do all the good stuff from 5G, and then focus on the things that need additional work. So I think that's going to be the critical thing.
So you each of you kind of brought up different elements, but you obviously agree that there's a lot of things that we're going to working on. One thing is the kind of the idea, Dale, of cloudification of networks. And so let's just we've seen some of that with 5G networks. And where do you see that in the future? Do you see the cloudification of 5G networks to continue to progress as we look at the 6G or anything like that, or or
Yeah.
or is there going to be some even something beyond that we're not even thinking of right now? That's beyond that. But do you look at the evolution of cloudification of 5G networks continuing to 6G, or where do you see that?
Yeah,
It will
for
be
sure.
sure. Go.
I'm gonna let Dale go first, and then I'm gonna let Ravi and Mazin talk about it.
Yeah, sure. Yeah, I personally do. Yeah, I think this is going to be a huge enabler, in this space of, getting things to scale as we talked about. But then also just this whole idea of cloudification, and we've gone from the cloud, now we've gone to some edge level of the network in order to address things like latency and have, enable these new applications like, XR and VR. So I think that'll continue to push out. And what I mean by that is, can we get this to go from an edge node of the network to the actual devices themselves? Can we orchestrate the devices? That's a major hurdle in this equation. And can we do that in the 6G timeframe? If we can, then we can deploy things like AI ML all the way down to the devices, do it at scale, do it in a something that's a manageable type of atmosphere. So will that happen in 6G timeframe? Let's see. But I think that's an interesting question to kind of look at from a cloudification perspective, is just expanding the cloud even further and incorporating the devices. So that's one aspect, at least, in addition to the scalability that we talked about already.
Yeah, Ravi and Mazin. I'll go Ravi first, then Mazin. Is cloudification going to continue to make progress as we move to 5G and 6G?
So I'm seeing the evolution of edge infrastructure, Chris, and tell you the fact, we started with 3U, 5N kind of arrangement at a metro, then we came further down to a telco, and then it has become a 1U kind of arrangement. But 1U also, the problem was everybody was just focused to a 3-sector RAN, and that's it for telco. And then later on at an upper level, at a metro level, you're going for a core and then RIC and other facilities. But if you think about it, if you're going for a cross-stack optimization, if you're talking about communication sensing, all those things needs a very different breed of edge infrastructure we are talking about. In terms of even like if you think about the edge infrastructure, I'm seeing a very different kind of hardware coming, where I think a less and less load to your main processors, and more load going to your accelerator platforms, which is doing a heavy lifting on FEC side of it, and multiple other areas, floating point operation. So I'm seeing a very different kinds of compute fabric coming even up to the telco level. You can say that like PCMCI Express cards, which is specific to ASIC or maybe FPGA, even like nowadays DPUs, there are multiple other things that also come up. So I'm seeing a very different breed of hardware coming, even at a telco level. And you also need to do a lot of offloading from the devices like Oculus and other smart glasses and all. So you need a more powerful, many-fold more powerful edge infrastructure at the telco end. So of course, I'm seeing a lot going to that. Along with that, because of the encryption piece is also coming in a very big way. So there are changes over there, and of course, GNSS and other things. So I'm seeing a next generation of hardware coming for 6G, which will also accommodate any and every expansion for 5G too.
Okay.
So yes.
Great. Mazin, your thoughts?
So let me just share this with you. I mean, the way we run our Google network, which we are pretty much very close to an autonomous network. It's an intent-based network where our workloads are containerized, distributed across edges, core, and we're able to orchestrate applications across that ecosystem, basically through just intent. We are able to do the orchestrations, we're able to do the automation, that closed loop automation, with pretty much very little human touch, okay? We're applying those principles to how telcos are moving towards that autonomous network I talked about earlier, which to me is a key principle for us to scale 6G. That is a must for us to do, as we are also getting into distributed clouds, and as we are putting those workloads out. I am seeing things going in the right direction. Let me give you just a few evidence of that. We're starting to move more towards programmable network. We're starting to think of the core as just a bunch of containerized services. We're doing the same thing with the RAN for the CU and the DU. There's the vRAN, which will evolve to the ORAN and standardizing some of the interfaces. We're going to do the same thing with the transport. We're looking at the devices the same way. We're definitely seeing the move towards cloud native. Absolutely, there is a huge, huge interest towards basically that in a distributed cloud. The other thing we're seeing, which is something we announced with 30 other partners in 2-3 weeks ago, is that we actually don't have a way to orchestrate these containerized cloud native network distributed ecosystem. We don't. We know how to use technologies like Kubernetes for applications, simple compute, networking, storage, etc. But network workloads are very, very different. And so a community came up with, under Linux Foundation, this umbrella of Nefio, looking at exactly that. Is it how do you standardize, how do you extend the Kubernetes framework, and how do you allow that to sort of manage and orchestrate network functions? That standardization of these northbound APIs, the OSS, BSS, all of those efforts are important for us to get to that autonomous ecosystem. So I am seeing the move, and I think this is going to be pretty radical by the time we get to 6G.
Okay, great, man. We're flying through our time here today on this panel. So I just want to end up with a last question, really about your final thoughts. And I want you to picture yourself. Each of you is a CEO, and you're a CEO of a new company, and you got 100 employees in front of you, and they're the brightest technology minds out there. Could be any industry, and each of you is a CEO, and the company is called 6G. So when you're addressing your employees for that very first time, at their very first day of what you're going to do, what would you tell them are the key challenges and opportunities as we look to the next generation of mobile technologies? So what would be the key challenges and opportunities that we are going to be looking at as we move into the next generation of technologies? Dale, any final thoughts to tell your employees?
Yeah, I'd say the key challenge is, it's kind of echoing kind of some of the storylines we talked about already, is, we can define a technology, that's one thing, but to actually deploy it at scale is really tough, right? Okay. So I would say defining technologies, methodologies, processes that can enable us to do that. We mentioned the cloud is one. So I think that's a big challenge, as well as an opportunity. But getting more to a specific opportunity, I see, going forward, there is an opportunity for the 6G system to be more personalized, more user aware, right? Yeah. So enable the system to kind of know a little bit more about the user, whether know about the user's location, what devices they're doing, what they're transitioning between devices, applications, having more information awareness and state about the user, and then meet the user kind of at those times when the user is doing context switches, when they're moving locations, moving devices, moving applications. I think that's an area that's going to be well served by AI/ML and intelligence within the network, and make things work just seamlessly, right? So if you're switching devices and whatnot, things just work. So I think that's an opportunity, that I wanted to throw out there.
Great. Ravi, final thoughts. You got 100 of the great tech minds in front of you. You're the CEO of a company called 6G. It's their first day. What do you tell them are the key challenges and opportunities as you move to the next generation?
Shortly, I think all the challenges are the opportunities, first of all. And definitely, I would like to focus with my team mainly to the use cases first, because ultimately, unless the use cases are not prioritized, the technology will never be enabled. So out of 8 major use cases categorized, whether it's cognitive network, connected sustainable world, network compute fabric, programmable physical world, limitless connection, connected intelligence, Internet of Senses, and digitized and trustworthy systems. These are, I think, 8 major areas, and I would like to focus probably 2 or 3 of them, which can really, really give me a market. And of course, the very first priority in terms of challenges will be my digital platforms, including your cognitive infra, kind of native security, of course, a high capacity compute fabric, the new next generation of edge infra. These are some of the major challenges: cross-stack optimization, hardware and algorithm co-development. These are some of the areas which are like, and because I'm heavily engaged with academia also, and I know that these are the pain points where the world is really focusing. We focus, and probably I think sooner the better, be the front runners to make a blend with all the 8 different use cases I've talked about.
Okay,
So
Mazin, you got 100 employees in front of you. First day, what do you want to tell them are the challenges and opportunities as you move to the next generation?
Well, first, they're in the right area. It's the most exciting thing they can ever work on, for sure.
Yep.
I'm going to blend a little what Ravi and Dale said. Number one is that we still don't know what the killer apps are for 5G. I just want to be very honest about this, okay? The killer apps and the apps is what's going to drive a lot of the requirements, and it drives a lot of the consumption of how far we go basically with 6G. So applications, and Ravi talked about some of those applications. Applications are going to be really key for us to have that driver. The consumption is important. That's going to basically make everything else happen, okay? The second thing Dale mentioned is scale. I come back to that scale to be a really important area. And scale we're looking at technologies like digital twin. We're looking at challenges like, how do you handle when you're looking at scale? Can you scale in a virtual world and then you go and map it into the physical world? Can you sort of figure out how you address, when you're scaling and densifying, how do you address interference? That's a big issue. How do you address signal strength and coverage when you can't get into you can't penetrate through a building because you're dealing with terahertz and ultra high frequencies? So scale to me has many elements and many dimensions. We have to address scale for us to make even 5G, advanced 5G and 6G basically to a reality. The last one is the programmable network. It's that autonomous network. It is way too expensive the way we're building 5G today. I mean, the amount of money that's spent building per site, it is just crazy. There's absolutely no way that can scale. That network needs to be software based. We have to sort of reduce the human touch, and which means we have to invest more into orchestration. We have to standardize some of the interfaces with the OSS, BSS systems, and handling it across a cloud native distributed network. So I see tremendous opportunities for people to be jumping up and down, but those are the 3 areas I would want to focus on.
All right, great. Well, I would like to thank Ravi, Mazin, and Dale for your time today to share your thoughts in this panel. I'm Chris Pearson. I'm president of 5G Americas, and as you can guess, I'm very bullish on 5G, but also understand that we are always innovating in our industry. There's a huge innovation roadmap with 5G, 5G Advanced, as we move to 6G, and obviously 6G is going to be here someday, so we are very much involved in the various areas of that. If you want anything on our website, it's free to download at 5gamericas.org. I would like to thank the Small Cell Forum. 5G Americas is an MOU partner with them. We work with them closely and really appreciate that partnership with the Small Cell Forum. So once again, thank you to Dale, Ravi, and Mazin. I wish you the best day, and out there in the virtual world, have a great day. Thank you very much.
Thanks a lot, Chris.
Thank
Take
you.
care.
Thank you. Bye-bye.
Bye.